Trachyte is an igneous volcanic rock with an aphanitic to porphyritic texture. It is the volcanic equivalent of syenite. The mineral assemblage consists of essential alkali feldspar, relatively minor plagioclase, and quartz or feldspathoid such as nepheline may also be present. Biotite, clinopyroxene and olivine are common accessory minerals. Chemical composition. Chemically, trachyte contains 60 to 65% silica content, less silicon peroxide than rhyolite and more than dacite. These chemical differences are consistent with the position of trachyte in the TAS classification, and they account for the feldspar-rich mineralogy of the rock type. Mineralogy. Trachytes usually consist mainly of cyanidine feldspar. Very often they have minute irregular steam cavities which make the broken surfaces of specimens of these rocks rough and irregular, and from this character they have derived the name. It was first given to certain rocks of this class from Auvergne, and was long used in a much wider sense than that defined above. In fact, it included quartz trachytes and oligoclase trachytes, which are now more properly assigned to andesites. The trachytes are often described as being the volcanic equivalents of the plutonic syenites. Their dominant mineral, cyanidine feldspar, very commonly occurs in two generations, i.e., both as large well-shaped porphyritic crystals and in smaller imperfect rods or laths forming a finely crystalline ground mass. With this there is practically always a smaller amount of plagioclase, usually oligoclase, but the potassium feldspar often contains a considerable proportion of the sodium feldspar, and has rather the characteristics of an orthoclase, a cryptopyrite, than of pure cyanidine. Rhomb porphyry is an example, with usually large porphyritic rhomb-shaped phenocrysts embedded in a very fine-grained matrix. Quartz is typically rare in trachyte, but tridymite is by no means uncommon. It is rarely in crystals large enough to be visible without the aid of the microscope, but in thin sections it may appear as small hexagonal plates, which overlap and form dense aggregates, like a mosaic or like the tiles on a roof. They often cover the surfaces of the larger feldspars or line the steam cavities of the rock, where they may be mingled with amorphous opal or fibrous chalcedony. In the older trachytes, secondary quartz is not rare, and probably sometimes results from the recrystallization of tridymite. Of the mafic minerals present, augite is the most common. It is usually of pale green color, and its small crystals are often very perfect in form. Brown hornblende and biotite occur also, and are usually surrounded by black corrosion borders composed of magnetite and pyroxene. Sometimes the replacement is complete and no hornblende or biotite is left, though the outlines of the cluster of magnetite and augite may clearly indicate from which of these minerals it was derived. Olivine is unusual, though found in some trachytes, like those of the Arso-Inischia. Basic varieties of plagioclase, such as labradorite, are known also as phenocrysts in some Italian trachytes. Dark brown varieties of augite and rhombic pyroxene have been observed but are not common. Apatite, zircon and magnetite are practically always present as accessory minerals. Trachytes, being very rich in potassium feldspar, necessarily contain considerable amounts of alkali. In this character they approach the phonolites. Occasionally minerals of the feldspathoid group, such as nepheline, sodalite and leucite, occur, and rocks of this kind are known as phenolitic trachytes. The sodium-bearing amphiboles and pyroxenes, so characteristic of the phonolites, may also be found in some trachytes, thus agerine or agerine. Augite forms outgrowths on diopside crystals, and rebeccaite may be present in spongy growths among the feldspars of the ground mass. Trachytic rocks are typically porphyritic, and some of the best-known examples, such as the Trachyte of Drachenfels on the Rhine, show this character excellently, having large cyanidine crystals of tabular form an inch or two in length scattered through the fine-grained ground mass. In many trachytes, however, the phenocrysts are few and small, and the ground mass comparatively coarse. The ferromagnesian minerals rarely occur in large crystals, and are usually not conspicuous in hand specimens of these rocks. Two types of ground mass are generally recognized: the trachytic, composed mainly of long, narrow, subparallel rods of cyanidine, and the orthophyritic, consisting of small squarish or rectangular prisms of the same mineral. Sometimes granular augite or spongy rebecite occurs in the ground mass, but as a rule this part of the rock is highly feldspathic. Glassy forms of trachyte occur, as in Iceland, and pumiceous varieties are known. But these rocks, as contrasted with the rhyolites, have a remarkably strong tendency to crystallize, and are rarely to any considerable extent vitreous. Geographic distribution. Trachytes are well represented among the Cenozoic volcanic rocks of Europe. In Britain they occur in skarns, lava flows and as dikes or intrusions, but they are much more common on the continent of Europe, as in the Rhine district and the Eifel, also in Auvergne, Bohemia and the Eugenian Hills. In the neighborhood of Rome, Naples and the island of Ischia, trachytic lavas and tuffs are of common occurrence. Trachytes are also found on the island of Pantelleria. In the United States, trachytes crop out extensively in the Davis Mountains, Chisos Mountains, and Big Bend Ranch State Park in the Big Bend region, as well as southern Nevada and South Dakota. In Iceland, the Azores, Tenerife and Ascension there are recent trachytic lavas, and rocks of this kind occur also in New South Wales, Queensland, East Africa, Madagascar, Yemen and in many other districts. Among the older volcanic rocks, trachytes also are not scarce, though they have often been described under the names orthophyre and orthoclase porphyry, while trachyte was reserved for tertiary and recent rocks of similar composition. In England there are Permian trachytes in the Exeter district, and Carboniferous trachytes are found in many parts of the Central Valley of Scotland. The latter differ in no essential respect from the modern representatives in Italy and the Rhine Valley, but their augite and biotite are often replaced by chlorite and other secondary products. Permian trachytes occur also in Thuringia and the Saar district in Germany. Closely allied to trachyte is the rock type called keratophyre, which is the sodium-rich plagioclase equivalent of trachyte.